Hi there and welcome to this next video in an integrated math 2 video series. Let's go ahead and start with our warm-up for today before we get into our lesson. Alright, so in number 1 here, what is 40 plus 60, or times 61? Might want to start out with 40 times 60. 4 times 6 is 24. 40 times 60 would be 2,400. And then 40 times 1 would be 40, so 2,440. Okay, number 2, given y equals negative 3x plus 18, what is the y-intercept? X-intercept. So the x-intercept is the x value in which y is 0. So when y is 0, your equation will look something like this. So what x value produces 0? And you can either think about it, just by looking at it, trying to inspect what would make that happen, or you can actually solve it. So we're going to subtract 18 on both sides. So you get negative 18 equals negative 3x. Divide by negative 3 on both sides, and you'll get over here x equals negative 18 divided by negative 3 is positive 6. And so our x-intercept here, the point is 6, 0 would be the point there. Okay? Number 3, write down the symbols for greater than. So greater than, let me erase some of this stuff first. Greater than is that. So you always read it left to right. Left to right. And so greater than, the distance between these 2 points is greater than the distance between these 2 points over here. And so that's one way you can think about it. Less than, again going left to right. So whatever's over here is less than whatever's over here. Again, the distance between these 2 points is less than these 2 points. Greater than or equal to. So greater than is going to be the same thing, like this. Or equal to, you put a little line below it saying it's either greater than or the value itself. And so same thing with less than or equal to. So how would you write x is greater than negative 6? X is greater than negative 6. All right, number 4. Xavier has a part-time job and saves $9 of his hourly pay for the purchase of a new laptop that costs $648. He has 80 saved already. It says write a function g of n that produces the total amount he has saved after n months. So let's think about that one for a second. Write a function g of n. So let's just do that down here. G of n equals, saves $9 of his hourly pay. So per hour he's saving $9. So that's going to be our reoccurring amount. For every increase of 1 in n, we're going to go up 9 in how much he saved. So n is the number of hours he's worked. He saved 80 already, so that's like the initial amount that he's starting with. And produce the total amount he has saved after n months. So we don't really need this value right now, right? This value doesn't really mean anything yet. Right now we're just trying to come up with a function that represents the amount he has saved after n months. So he saved this much after n months. All right, 9 times n plus 80. All right, number 5 says find g of 4 and describe what it represents. So g of 4, that means we're going to substitute 4 in for n and simplify. 9 times 4 is 36 plus 80. 80 plus 30 would give us 110. So 116 when you add the 6 in there as well. So that means after 4 hours of work, he has saved 116 total. So 80 that he already has, plus working 4 hours, he earns 36, making a total of $116 that he saved. So that's what that represents in the context. All right, our goal for today is to write and solve linear inequalities with real world context. So last time we looked at linear equations, equation meaning equal to. Now we're thinking about inequalities. So unequal meaning they're not equal to. That's what a linear inequality means. So let's talk about the same situation. So we have Xavier. He's wanting to save up $648. Again, the function for how much he has saved is 9n plus 80. And we want to know, it says write and solve an inequality for how many hours he must work to buy the laptop. So when is the amount he has made, or that he has, when does that surpass $648? When is that greater than $648? So in fact, let's see, he just needs 648. So he could have exactly 648. So it could be greater than or equal to. So when is 9n plus 80 greater than or equal to 648? So this time, I read it right to left. If we read it left to right, it would be 648. When is that amount less than or equal to how much he's made? Because then he'd be able to purchase it, right? So we're going to solve this. So we're actually going to use the same reasoning we used in our last video on how to isolate the variable. So same overall process. There's going to be really just one little caveat that we're going to add to that here in just a little bit. But for right now, we're just going to solve for n. So we're going to subtract 80 on both sides. Let's see, 80 minus 80 is just going to be 0, so it's going to leave 9n. Maintain that same inequality there. And then 648 minus 80, let's see, 648 minus 100 would be 548, but we're not doing 100, we're doing 80 instead. So it'd be not 48, but 68. All right, then we're going to divide by 9 to get n by itself. So n is less than or equal to, let's take out our calculator here. 568 divided by 9. 568 divided by 9. 63.1 or 63 and 1/9. So 63.1 repeating. Okay, so let's make sense of this. After 63.1 hours worked, he will have exactly 648. So let's read this. So n needs to be greater than or equal to 63.1 hours worked in order for him to have that amount. Now, if you think about hours worked, you don't really get paid for 1/9 of an hour. You work that whole hour, then you get paid. So let's make sense of this. Really, n needs to be greater than or equal to 64, right? So that he can have that amount. So he'll actually make a little bit more than 648 by doing that, but he needs to work at least 64 hours. So this says that n could be equal to 64 or n could be greater than 64. So again, n is greater than, these 2 points are further apart than these two. So n is greater than or equal to, if you read it right to left, n is greater than or equal to 64. And you can write it this way, n is greater than or equal to 64. Same thing, all right? In our next example, Susan is on vacation and wants to rent a bicycle to explore town. She pays a $10 flat fee to rent the bicycle, and then a $9 per hour fee as well. If Susan has $42 to spend, what is the greatest number of full hours she can rent the bicycle? So let's set up how much it's going to cost first. So that's going to be 9h plus 10, where h represents the number of hours she's going to rent the bike. 10 is that flat fee, and then we want the cost of renting the bike to be less than or equal to 42, right? the cost of renting the bike cannot be greater than 42 because we don't have that much money to work with here. It has to be less than or equal to 42. All right, so part of the process is setting up the inequality and then solving from there. So the first thing we want to do is subtract 10 on both sides. We have 9h is less than or equal to 32. So 9h is less than or equal to, let's see, divided by 9 here. Let's see, that's going to be a little bit over 3. 32 divided by 9 should be 3 and 5/9. So h is less than or equal to 3.5 repeating or 5/9. So the most, how many hours can she ride then? Right? The number of hours that she rents the bike has to be less than or equal to 3.5. And it says the number of full hours. So she can't ride 3.5 hours or 3.5 repeating hours. So how many can she afford then? And you got to make sense of it and use your reasoning skills. Sometimes you round up, sometimes you round down. We rounded up in the last example because we were talking about hours. They had to work to earn a certain amount. Here, we need to round down to 3 hours because now we're going the other direction where we can't afford more than what we have. So we can't afford 4 hours, right? We can only afford 3. So the number of hours that she can ride is less than or equal to 3. So she can ride for 1 hour, 2 hours, or 3 hours, but no more than that. So just kind of thinking through like how to reason, through this and figure out what are the possibilities, what are the intervals in which we can, in which our variable can take on. Okay, so let me give you a chance to try this one. Let's read it together and then I'll give you a chance. So it says, Terry has a goal to ride his bike at least 300 miles this summer. He has ridden 47 miles thus far, and there are 56 days left in the summer. Write an inequality to represent the average distance d in miles that Terry must ride each day for the rest of the summer to achieve his goal. Okay, so let me give you a second to try and figure out what's going on here and create this inequality. Okay, so he wants to ride 300, at least 300. So that's a key word there, is at least 300. So the amount he rides needs to be greater than or equal to 300. Okay, he has ridden 47 miles thus far. So that's like the initial amount or starting value. So 47 thus far. And let's see, 56 days left in the summer. So if he rides an average of d miles a day, so it's going to be 56 d, right? If he travels on average d miles per day, he's going to multiply that by 56, and this is going to represent the total number of miles he rides the rest of the summer, plus the amount he's ridden already, equals or greater than or equal to his goal, which was 300. So that's the inequality. Now let's go ahead and try and solve this together. So 56d is greater than or equal to, if we subtract 47 on both sides, let's see, it's going to be 253. So then we're going to divide 253 by 56. 253 by 56. All right, 4.517. We'll just round to 4.5. That's going to be miles on average per day. Okay, so as long as he does, and he averages at least 4.5, so he could average, 4.6, 4.7. He could, and that would be fine as long as is either equal to that amount or greater than that amount, he will then reach his goal or achieve his goal for the summer. Okay, so as I said earlier, there's a little bit like one caveat that we're going to add to this that makes it a little bit different than solving equations. And so it's going to be involving dividing by a negative number. And let me explain kind of the reasoning here. So if we compare 1 and 2, 1 is less than 2, right? But what happens if we multiply both sides by a -1 or divide by a -1? So if anytime we multiply or divide by a negative number, so let's see what happens. If we multiply or divide by a -1, we're going to get -1 and -2. Well, what's the relationship between those now? What's the relationship between -1 and -2? Well, let's see. We started out with 1 and 2, right? And then now we've got -1 and -2. Starting out, 2 was greater than 1, right? But what happens when we multiply or divide by a negative number? Oh, -2 is now less than -1. So what happens is the relationship between the two is it reverses, right? Now -1 is actually is greater than -2. Okay. Same thing. Let's move on to the next one here. Okay, right now -3 and -4. Right now, -3 is greater than -4. But when we multiply or divide by a -1, so basically changing both sides, the signs of both sides, it's going to give us 3 to 4. Okay, well we all know that 4 is greater than 3. All right, so what happened? Well, -3 is what we start out with, then -4. And then when we switch the signs of both, we get 3 and 4. What happened is the relationship between them changed because in general, a greater negative number is actually less than a smaller negative number, which is not the case right over here. So that means that 3 is less than 4. All right, so let's generalize this. If we have A and B, let's say that A is less than B. All right, so I'm not sure where A and B are because we don't know what value they are, but A is less than B. So we can kind of generalize it that way. All right, if we negate both sides, so -A and -B, that means -A is going to be just the same distance from 0, but on the other side here. So -A and -B. Which one's greater? Which one's greater, -A or -B? -A is greater, so -A is greater than -B. In general, anytime we multiply or divide by a negative number, it changes the relationship between the two. If one was greater than the other one, then now it's less than. If it was less than before, now it's greater than. So you might say, flip the sign. Is what some people like to call that. But I want you to understand why we do that, right? This idea, this picture right here shows you why we flip the sign. Why does that relationship change? It's because a greater negative is actually less than a smaller negative, all right? So let's kind of put that to use here. It says, move this over here real quick. It says Tracy has $45 and gets paid $6 a day starting tomorrow. Maybe an allowance or something like that. Meanwhile, Michael has $112 and buys a coffee for $3 each morning starting tomorrow. How many days from now will Tracy have more money than Michael? All right, so take a minute and see if you can solve this problem. All right, so let's start from the beginning here. Tracy has $45 and gets paid $6 a day. So 45, this is Tracy. starts 45, but then gets paid $6 a day, so 6D, you can put X there if you want to, but D for days. And then Michael, so Michael over here has $112, so that's the constant amount or starting amount. But let's see, buys a coffee for $3 each morning. So he's losing $3 a day. So it's minus 3D. All right? And then we want to know, when does Tracy have more money than Michael? So when is Tracy greater than Michael? All right, so let's see if we can solve this. And I'm going to do something on purpose here just to bring out this idea of what we just talked about, multiplying and dividing by a negative. So let's start with, we're going to get the D by themselves over here. So I'm going to subtract 6D from both sides. So we get 45 over here is greater than negative 3D and negative 60. It makes negative 9D plus 112. Let's subtract 112 from both sides. So it's going to be, let's see, it's this one's 55, 67. So it'll be negative 67 greater than negative 9D. Okay, so the next step here, we're going to get D by itself by dividing by negative 9. Okay, now it's going to be approximately 7 point something over here. But the key here is when we divide by the negative, we divide by negative 9, it's going to actually change this relationship to being less than D. Right, we're going to get D when we divide negative 9 by negative 9, we just get the D here. So it's going to be positive 7 point something, let's see exactly, 7 and should be 4/9, I think. Let's just check here. Yeah, 7 and 4/9. So 7 and 4/9 are 7.4 repeating days. So when the number of days is greater than 7.4 repeating. So just keep in mind here, like anytime we divide or multiply or divide by a negative, it's going to change the relationship between your two sides. So just make sure and remember to do that. So D is greater than 7.4 repeating. So in this case, we would say anything greater than or equal to 8 days. Because anything above 7.4 repeating, but if we do it in an integer number of days, then it would be 8 days and beyond. So anything greater than or equal to 8 days. There. Okay. All right, just as we did last video, an open middle problem here. It says using the digits 0 to 9 at most one time each, fill in the boxes to create an inequality whose solution set is x is less than negative 1/2. X is less than, not equal to, just less than negative 1/2. So take a second and see if you can fill in the boxes here. Again, using the numbers 0 to 9 at most one time each. So you can't duplicate numbers here. In each box, just put one number and see if you can create one that has a solution of negative x is less than negative 1/2. Okay, so in this scenario, a lot of different options here. Let me show you a few. Let's just start with this first one here. So 2x plus 5 is greater than 4x plus 6. All right, so let's see, 2x plus 5 is, we're going to, I'm going to subtract 2x on both sides. Again, what that's going to do is it's going to keep my x positive over here. Now, if I were to subtract 4x on both sides, I'd be getting a negative, which is fine. You'll end up having to switch the sign, or switch the relationship, but you can do that. If you do it this way, you don't have to worry about that. So now we can subtract 6 on both sides, and we get 2x over here, and negative 1 over here. So we're going to divide by 2. on both sides. So we're going to get negative 1/2, or, and we can rewrite this, we can switch everything here. X is less than negative 1/2, so x is less than negative 1/2, which is what we wanted there. Notice, did we divide by a negative here? No, we divided a negative number by a positive number. So this is still positive. We did not divide by a negative, so we do not have to switch the sign when going from this step to this step. It's teacher preference. I'd be okay with writing it this way, but I think this is probably the more accepted notation, with x being on the left side there. But hopefully you can understand and be able to interpret both of those. So x is less than negative 1/2. All right, let's check out the graph of this one. I want to show you a graphical perspective. So, and show what that looks like, just as we did in our last video. 2x plus 5, 2x plus 5, and then the other one is 4x plus 6. And we wanted to know, let's see, where is 2x plus 5? So where is the blue one? All right, where is the blue one greater than the red one? All right, the blue one is 2x plus 5. This is 2x plus 5 here. And this one is 4x plus 6. When is the blue one greater than the red one? So basically we're looking for where is the blue one above the graph of the red one? Well, how about negative 5? At negative 5, is the blue one above the red one? Yes. How about negative 4? Yes. At negative 3? Yes. Negative 2? Yes, the blue one's still above the red one. At negative 1, the blue one's still above the red one. How about negative 1/2? Okay. At negative 1/2, the blue one and the red one are equivalent. Okay, so at negative 1/2, the blue one is not greater than the red one. How about if we go on to 0? Oh no, the red one's now greater than the blue one. So for all x values less than negative 1/2, so to the left of negative 1/2, we always determine it based on the x value. For all x values less than negative 1/2, the blue one is greater than the red one. So that's what it looks like graphically in terms of an inequality. Okay, a couple more here and then we'll finish up. This is a couple T&Ready problems, T&Ready type problems. It says solve the inequality. So take a moment and see if you can try and solve this problem. All right, so in this case, we've got a fraction over here. What I'd like to do first is multiply both sides by 4. So I'll multiply both sides by 4. Again, going back to our last video, if we multiply both sides by 4, we have to multiply the whole sides by 4. So that's going to be 16x minus 28, if we distribute the 4 inside here to both of those, is greater than or equal to, if we multiply this side by 4, 4 divided by 4 is just 1. So what that's going to do is it's going to multiply this numerator by 1, which is basically just the numerator. So negative 12x plus 14. From there, I'm going to add 12x to both sides. And there's a number of ways you could do that, but that's just my preference there. So it's going to give us 28x minus 28. It's greater than or equal to, and then over here we're just left with 14. So 28x, we're gonna add 28 to both sides. So it's going to be 28x is greater than or equal to, let's see, 14 plus 28, let's see, that's going to be 42, I believe. Let's check that, let's see. 28 plus 10 would be 38, plus 4 more would be, 42. All right, and then we're going to divide here. Let's see, 28, we're going to divide by 28 on both sides. So x is greater than or equal to, notice we're not dividing by a negative number, so we don't have to worry about switching the sign there. That's going to be 1.5 or 1.5. So x is greater than or equal to 1.5, which would be C. Again, you could check it if you wanted to. You could graph the left side. So going back to our original problem here, you could graph the left side. If you're using a TI-84 calculator, you could do that in Y1, and then graph the right side in Y2, and see when the graph of the 4x minus 7 is above or equal to, so the intersection actually would count here, above or intersect the right side, the right equation. And it should be all x's greater than or equal to 1.5. All right, as we did in our last video, one of the last examples we looked at was solving a linear equation with coefficients represented by letters. We're gonna do the same thing here, but an inequality. So in this case, we have an inequality 51, let me write it out here, 51 less than or equal to bx plus 9, and it says, for what value of b will result in the solution of x is greater than or equal to 7? So let's just kind of think this through here. X is greater than or equal to 7. Well, let's just try and solve what we can and see what happens. So we're going to subtract 9 on both sides. So it's going to be bx less than or equal to, let's see, 51 minus 9 is going to be 42. All right, so we want it to end up being, let's see, we're going to divide by b, and we want it to be x is, I'm going to just switch things around here, x is greater than or equal to 7. So what value of b would make that happen? 42 divided by what is 7? Be 6, right? So an x value or b value, b equals 6 would be our answer. When b is 6, you get 42 divided by 6 is 7. All right. Any questions on that? Feel free to reach out to your teacher and work on that one as well. I know it's a little more confusing in introducing those coefficients represented by letters, but hopefully you can kind of use your reasoning skills, problem solving skills to figure out what the missing value must be. All right, so hopefully that reaches our goal for today, which is to write and solve linear inequalities within a real world context. We also looked at it graphically, and then we also looked at it with coefficients represented by letters. So we're going to continue to use this idea of solving equations, basically doing the inverse operations in the reverse order, and we're going to continue to use that skill in our next video when we solve literal equations for a particular variable. So join us then.